Hello and Assalamualaikum warahmatullahi wabarakatuh. Today, I am going to present my final year project entitled Vehicle Detection and Classification with Different Speeds and Sizes using LTE-Based Passive Forward Scattering Radar and NEMO Handy. Firstly, it is about radar system. Radar system used to detect location and distance of a target. For instance, it can detect aircraft, watercraft, and motor vehicles. It has two categories, which are monostatic radar and bistatic radar. For monostatic radar, transmitting and receiving antennas are close to each other at same location. Meanwhile, for bistatic radar, transmitting and receiving antenna are placed apart from each other at some distance. Moving on into forward scattering radar (FSR). It is included in bistatic. The receiver is located at some distance from transmitter. The targets pass by transmitter and receiver with bistatic angle reaches or approaches 180 degrees. Next is passive forward scattering radar (PFSR). It detects targets that pass by commercial transmitter and radar receiver that is placed along the baseline. It cannot be seen, but it can detect targets. PFSR is low cost and much simple. I have listed 3 problem statements and objectives for this research project. First is about speed trap. Speed trap system need an improvement in order to detect high-speed vehicles. Second is illegal logging. These activities need to be taken seriously. And third is about border protection. Border protection needs an upgrade so vehicles cannot go through illegally. As for the objective, to investigate the PFSR system utilizing LTE signal of vehicle movement on the road. To detect and classify the vehicle Doppler signature with 3 different speeds and 4 vehicles type at 2 different lanes. And third, to capture signal strength of 4G LTE, focus on RSRP and RSRQ using NEMO Handy for PFSR support system at 3 different places. 3 different experimental sites has been chosen for this research project. Firstly, it is at Kampung Nyalas, located in Melaka, where the distance between transmitter and receiver is 914.96 meter, where this is one of the furthest distance among other experimental sites. Next is at Kampung Bangkong, located in Tanjong Sepat, Selangor. The distance between transmitter and receiver is 275.27 meter, and this is one of the shortest distance among other experimental sites. And last experimental site is at MAEPS, which is located in Serdang, Selangor. The distance between transmitter and receiver is 451.37 meter. 4 different types of vehicles are used for this experimental work. The size that will be implemented are from extra small, small, medium, and big. For extra small, we use motorcycle, which is Yamaha Ego. For small, we use compact car, which is Pro2 Asia. And for medium, we use sedan, which is Proton Wira. And for big, we use SUV, which is Toyota Harrier. Additionally, 3 different speeds are used for this vehicle detection, from the slowest speed, which is 20 km per hour, to 40 km per hour, and lastly to 60 km per hour. The vehicles will pass by through transmitter and receiver, through far lane and near lane. For near lane, the distance between radar receiver and the target is 6 meters, and this is the time domain of the moving target for near lane. Meanwhile, for far lane, the distance between radar receiver and target is about 12 meters, and this is the time domain of moving target on far lane. Last part of methodology is signal processing, which is shown in the chart below. First is signal detection. Time domain detection is captured in 20 seconds. From there, signal will be selected in 2-second time domain that consists of Doppler signature of the vehicles. In data denoising, it will reduce the unwanted signal. And next is power spectral density, where time domain is converted into frequency domain. Next is principal component analysis, where it uses training and testing data, and it will classify into its own cluster. And lastly, classification can be identified based on the vehicle's detection. Same goes to NEMO Handy. The data will be recorded and selected to do some extraction in order to come out with graph of the classification. For the result in time domain graph, we can observe that as speeds goes higher, the time taken is lesser, causing the Doppler signature to shrink, and therefore the higher speed has greater amplitude. Meanwhile, in power spectral density graph, we can see that 20 km per hour has the lowest frequency, followed by 40 km per hour and 60 km per hour, which has the highest frequency. This shows that higher speed with shorter time taken gives higher Doppler frequency. Meanwhile, in principal component analysis, all PCA for 4 types of vehicles is successfully classified into its own cluster as no data overlapping into each other. Next is analysis on near lane and on far lane. For near lane, it has higher concentration of training and testing data in their region. This is because of higher sensitivity of radar receiver at near lane. And for far lane, the data in cluster is a bit spreaded and cluster become closer to. So we can see that near lane has better analysis compared to far lane. But both near and far lane is successfully classified without overlap. Next is result based on NEMO Handy. For NEMO analysis, the parameter collected is RSRQ and RSRP, which is reference signal receive quality and reference signal receive power. For the blue data is located at MAEPS. MAEPS has an excellent condition because less user at that time. Meanwhile, the blue data is located at Kampung Bangkong. Kampung Bangkong is also categorized as excellent because less user at this area. And the green color is located at Kampung Nyalas. For Kampung Nyalas, the result is classified as good because many users at that time and the tower signal strength dropped. The last part is conclusions. PFSR system utilize LTE signal is successfully accomplished and is proved by the experimental works based on detection and classification of vehicles with 3 different speeds on near lane and far lane, also different types of vehicles along with 3 different locations. PFSR successfully classified the Doppler signature of vehicles detection because if the speed goes higher, the Doppler signature shrink as appear in time domain graph and the Doppler frequency is increased in power spectral density. The parameters of RSRP and RSRQ in NEMO Handy shows excellent conditions for MAEPS and Kampung Bangkong, while good conditions for Kampung Nyalas. Both conditions successfully supported the PFSR radar system in detection and classification of moving targets with 3 different speeds and 4 different types of vehicles.